Hello, everybody. This is Skip Elsheimer. Welcome to the AV Geeks Lunchtime Streaming Show, where we watch old 16mm films. And I am pre-recorded today because we're about to have some really bad weather. It's going to be windy, maybe tornadoes, maybe hail. And so that generally means the power goes out. And we had to go out for no reason a week ago. So I'm preparing myself by uploading this show. Anyways, so be thinking about wind and rotating made me think about helicopters for some reason. And so we're going to be watching a series of films today about helicopters. First, a silent footage from a newsreel from Paramount about helicopters. I think it's a compilation of different clips about helicopters. Then our good friends at Encyclopedia Britannica talk about the helicopter and the concept behind it. Then a Cornet film called Helicopter Ride, which is a second edition version of Billy's Helicopter Ride. Then a promotional film called Skyways without Runways. And then finally, some footage that was shot in Alaska of wildlife in Alaska and the Yukon from a helicopter, which is called, what is it called? Honolulu in Yukon. And this looks like, I'm not sure if this is amateur footage or what the deal with this was. But anyways, we'll be back live tomorrow, and we will talk to you soon. Everybody hit the thumbs up, hit the like button, subscribe. Those are great ways to support us. And we will see you soon. Take care. And if you're in the midst of this, in the Triangle area or in the Piedmont of North Carolina, be safe. And I think some of you are also dealing with this, but it's frozen precipitation. So be safe in that as well. See you soon. Bye.
Modern aviation has made great progress in recent years. Huge airliners carry into the sky each day an ever larger tonnage of cargoes and passengers. Jet propulsion has made possible extremely high speed. Yet in one aspect, these aircraft have become more limited than before, since they need exceptionally long runways to take off and land. The need for an aircraft independent of huge airfields is being met today by the helicopter, which can land in any area big enough for its whirling rotor. Helicopters are being used today for a wide variety of jobs, which can't be handled by other aircraft. In larger cities, they are delivering thousands of pounds of mail every day from outlying airports directly to the post office. These craft can carry some 400 pounds of mail on each trip, and in some cities, trips are made throughout the day at 20-minute intervals. Flying over city traffic, the helicopter can land directly on the roof of the post office itself, in a fraction of the time needed by mail trucks, thus greatly speeding the delivery of mail. Helicopters have found important uses in the country too, where they are used for dusting crops, which would be damaged by ground equipment. The helicopter's great maneuverability makes it possible to spread dust over every corner of the field, no matter how irregular it may be. The sharp downdraft of the whirling rotor causes dust to swirl among the plants, thus giving them a more thorough coating. The helicopter's slow speed makes it useful for any kind of air search, and especially for inspections of such things as power lines and pipelines. If anything unusual is spotted from the air, the helicopter can hover to give the inspector a better look. Equipped with pontoons, the helicopter can land on water and can penetrate swamps which were previously inaccessible. In war, the helicopter has proved itself for many purposes. In addition to its use for observation, for direction of artillery fire, and for transportation of men and equipment, the helicopter has saved many a life by its ability to land directly on the battlefield in order to speed wounded men to base hospital facilities. But all these values will eventually be secondary to the helicopter's use as a passenger vehicle. Combining its ability to fly with the automobile's ability to go directly to and from its destination, this versatile craft is almost unlimited in the variety of uses to which it can be put. To understand the helicopter, let's first see what makes an ordinary airplane fly. It isn't the propeller which lifts the airplane off the ground. For example, jet airplanes can fly without propellers. But all ordinary aircraft must have forward speed to fly, and this forward speed is provided by the propeller. The reason speed is necessary lies in the shape of the airplane's wing. A careful examination will show that the wing has been designed so that its upper surface is more curved than its lower surface. Therefore, the distance from the front to the back of the wing measured along the lower surface is less than the distance from the front to the back measured along the upper surface. When the airplane is in motion, air rushes past the wing. The air passing the upper surface moves a longer distance in the same time as the air passing the lower surface, and therefore moves past the upper surface faster. This difference in air speed increases as the airplane itself moves faster, and creates a partial vacuum along the upper wing surface. The normal air pressure under the wing lifts it into this partial vacuum, which enables the airplane to fly. At first glance, a helicopter seems to be able to fly without wings. Actually, however, the rotor blades of a helicopter are shaped much like the wings of an airplane. The upper surface of the rotor blade is more curved than the lower surface. When When the rotor turns, air moves past it in much the same way that it moves past the wing of an ordinary plane. Thus, there is no need for the helicopter itself to be moving. When the blades move fast enough, they provide the lift necessary to raise the helicopter off the ground and permit it to hover. Thus, helicopters are called rotary wing aircraft, while conventional airplanes are called fixed wing. The helicopter's development stemmed from an earlier craft, the autogyro, shown in these historical films. It required a propeller for power, since the rotor was freewheeling and couldn't hover. Many devices first developed for autogyros are being used in today's helicopter. The helicopter is a free-swinging body hanging from the whirling rotors. The turning rotor sets up an action which tends to turn the body of the helicopter in the opposite direction. This action is called torque and is counteracted by a tail propeller called the anti-torque rotor. The tail rotor is used to turn the craft in any direction independently of the direction of travel. To understand how forward movement is accomplished, let's see what happens with a toy rotor like this. If you hold the rotor flat, it will fly straight up. But if you tilt it in any direction, it will fly in that direction. A helicopter rotor works the same way. Tilting it in any direction with relation to its shaft causes the helicopter to fly in that direction, whether it's forward, backward, or sideways. The direction of flight is determined by the tilt of the rotor, and not by the direction the nose of the helicopter is headed. Now let's take a ride in a helicopter. While the controls are comparatively simple, a helicopter pilot must be as thoroughly trained as the pilot of any other type of aircraft. A self-starter starts the engine, and after a careful warm-up, we're ready to take to the air. The collective pitch control, whose handle is also the throttle, determines the amount of lift which the rotor provides. Once in the air, the pilot uses foot pedals, which control the tail rotor to turn the machine in the direction he desires. The stick in front of the pilot controls the angle between the spinning rotor and its shaft. And when the stick is moved in the direction the pilot wants to travel, the helicopter is on its way. Flying a helicopter is quite a different experience from flying a fixed-wing craft. Although this craft can cruise at about 85 miles an hour, there's no need to maintain airspeed, so there's time to look around. Should the engine fail, the rotor would act much like a parachute to permit an emergency landing. But of course, most landings are with power. There are a number of different kinds of helicopters being flown today. Some are designed with two rotors, which turn in opposite directions. Each rotor counteracts the torque action of the other, and thus eliminates the need for an anti-torque tail rotor. Twin-rotor helicopters have been built large enough to carry 16 persons, with a gross weight of more than 14,000 pounds. The jet helicopter, powered by tiny jet engines on the tips of the rotor blades, works much like a fireworks pinwheel. The jet engines are the only source of power. Jet helicopters are simpler in construction, lighter, and easier to operate than conventional helicopters, although fuel consumption is very high. The continued development of this and other types of helicopters, with their unprecedented freedom of movement and the wide range of uses to which they can be put, holds great promise for the future of transportation. Who could have predicted the vast changes which the development of the automobile and the truck have brought about in our society? The potentialities of the helicopter are just as great. Its versatility as a transportation vehicle may eventually play an important role in reshaping the pattern of our daily living.
you must be here to see John Wright. Why don't you have a seat over there and I'll call him for you, okay? John Wright, please come to the front desk. John Wright, please come to the front desk.
Hi, I see you found your way here all right. If you're ready to go, I think we ought to get started. Why don't you follow me into the hangar? I'm glad you could get permission to come. It's always fun to show the helicopter to someone for the first time. This is the hangar through here. Here in the hangar is where they do the work on the airplanes and the helicopters. Jerry, are we ready to go?
Yeah, she's all set, John.
I remember the first time I looked at a helicopter. I just couldn't see how it could fly. I mean, it has no wings, just that big propeller. But later, as I learned more, I discovered that that big propeller really is a wing. It's called a rotary wing. It works because the air around us has weight and pressure. For example, when you're riding your bicycle and you stick your hand out like this, you can actually feel that pressure. And if you turn your hand up, you can feel the air lifting up on your arm. And that's what makes the wing and the rotary wing work when the engine turns the blades. The motor also drives the propeller in the back, called the tail rotor. Come on back. Without this, the helicopter would spin around and around when the blades are turning. So this tail rotor helps to hold the helicopter steady and point it in the right direction. Let's get in, I'll show you the controls. Okay, watch your step here. Now this is the busiest control in the helicopter. It's called the collective pitch stick, and it's what makes the helicopter go up and down. Pitch is the angle at which the blades cut into the air. The greater the pitch, the faster we go up. The pitch stick also controls the motor, because the more pitch you use, the more power you need to keep the blades turning at the same speed. But I guess what you'd really like to do is see how it feels to fly. There's really only one way to do that, so why don't you buckle up and we'll get started. Put these on, that'll make it easier for you to hear me.
Helicopter 887, Trent.
887 is on Ronson's west ramp for a west departure.
Helicopter 887, west departure approved. Wind calm, altitude 2996, clear for takeoff.
2996, thank you. You'll find that this is a whole new way of looking at things. we'd come down for a moment to show you something. The helicopter is really the only way we could have reached here, except for a hard day's climb. And that's what makes the helicopters so unique and important to a lot of people. They do a lot of very special jobs. They do construction work, rescue work, deliver mail to hard-to-reach places, serve as emergency ambulances, and recover space capsules at sea. And that's just a few of the things they can do. Let's head on into the city. I think you'll think about it differently after you've seen it from the air. I think we'll follow the highway in. Finding your way around in a helicopter can be pretty tricky. We do talk to control towers like airplanes, but a lot of the time we use a compass and maps. And sometimes we just fly low enough to read road signs and the highway markers. Helicopters fly lower than airplanes, but they do have to watch out for them carefully, and obstacles like power lines are something the pilot must always be aware of.
Helicopter calling TCA now, go ahead.
Yeah, cover 7171 north of the Lincoln on the west side at 1,000 coming into MAT Squawk 01.
Helicopter 887.
Roger, proceed between the runways 65527, traffic landing and departing runway 1.
East boundary, Big A.
Right to hold east 887.
Peterborough Tower, Suburban 32, down 1 for 1.
I say again, 32, follow the Cessna, head downwind, number 3.
Suburban 32.
Beat Alpha Sierra, taxi into position and hold. Safe at 65, turn left hotel, contact ground control clearance. Now, 887, you just by the radio towers east of the field?
That's firm.
I'd maintain altitude and clear to Atlantic traffic is on file for runway 1.
87. What we just landed on is called a rooftop helipad. Let's get out and take a look around. Here, let me help. Watch your step, it's a tall one. Many of the buildings in cities like this have heliports. It's usually the fastest way to get around. If you're wondering how to become a helicopter pilot, the best way, I think, is to start with an airplane and then try the helicopter. It's easier that way. Why don't we go back along the coast? It should be nice now.
helicopters that will carry more people and do more work. But for me, the best thing is that it gives you a way to see things very different from anything else.
About midnight on a very hot July night, the world was startled to learn about a sea disaster. Collision between the Italian liner Andrea Doria and the Swedish motor ship Stockholm. The overtones of holiday gave way to the quick pace of emergency, of rescue. Part of the scene of heroism and rescue was the distinctive shape of the helicopter, which made its unique contribution in time of trouble first when we were copter lifting wounded in Korea, and which has since become part of everyday life. Nearly a year before the Doria disaster, 2 hurricanes struck Tampico, Mexico in one 10-day period. The streets became torrents, and the people did not know whether to flee or where, or to sit in quiet resignation for disaster to strike. Here, too, the shape of a Vertol was a sign of hope in the sky. They had come from Pensacola on the aircraft carrier Saipan and were led by Commander R.C. Lefevre. What they and the Navy did in Tampico that week was an example of what America can achieve abroad when it mobilizes its machines and disposes them with its heart. Affectionately called Lefevre's Retrievers, the helicopters flew a total of almost 1,000 hours, dropping food to the stranded, lifting the threatened, evacuating people from areas where foundations were crumbling before the swift waters, where escape on foot was impossible and by boat too hazardous to try. They delivered babies and brought typhoid shots, and truly earned a well done. They saved a city, and today they are remembered in prayers in a far corner of a foreign country. A helicopter is delivered. Behind the Vertol helicopter's feats, the rescues, the multitude of service and civilian accomplishments, some glamorous, some workaday, lies the full strength and complexity of a modern industrial organization. An operation fully based on research and planning. From the huge plant of the Vertol Aircraft Corporation in Morton, Pennsylvania, to the peasant family awaiting rescue on a Mexican hilltop is a straight line, but it is a long one. The idea is not enough. Giant machines, skilled men, long hours, a well-planned organization. Each plays its part in this successful blending of precision and high-quota production. A press, accurate enough to make parts for a good watch and powerful enough to form steel, is needed to shape parts for a copter. And as ideas change, and they change and grow fast in the aircraft business, production methods and capacities must be maintained at a constant and often increasing level. The techniques of the assembly line have been brought into play by the tremendous and growing demand. Sub-assembly lines work on sections of the craft, speeding them carefully down the line to the points where they meet other sections. Speed was always possible, so was precision. Both together took a little doing. Final assembly. The front section is in place, the tail section brought to it by conveyor. This is the daily scene at the Vertol plant. The widespread facilities, the system of manufacture in operation, the air of a job understood, leading to a job done. All over the plant, the same process in all its stages moves in the same direction. The instrument console is installed, the key not only to the operation of the craft, but to its unique mobility, the quality which has earned it its place in our defense organization, our civil transportation, and those of our friends and allies. Like the instrument console, the transmission and rotor head unit is timed to reach the fuselage at the point of complete assembly. Included in this job of putting a craft together were not only the shell and the rotors and engine, but the controls, the drive system, auxiliary fuel tanks, electronic equipment for communication and navigation, and everything else a modern flying machine needs. The French are among foreign governments using Vertol aircraft. Elsewhere in the plant, a special organization to test and analyze each part of each helicopter before it's released. Data processing machines and computers solve copters' problems before they are met in the air. You can't assume it will be all right. Now is the time to test in safety, for performance, for reliability. Each rotor blade is put through stresses far beyond those it will ever meet in use, and its action under stress not only observed, but analyzed electronically. Gearboxes are tested under simulated flight conditions before they are installed. And finally, on the whirl tower, the rotor blades are put through their paces to check balance. A tracking flag is raised just to touch the whirling blades. If the marks they leave are close together and equally spaced, the blade assembly has passed. Assembled and tested and just about ready to go, a brand new Vertol helicopter, the achievement of a group, an aggregation of 5,000 people who spend their working hours bringing their individual contribution to the final product. are so many people, there must in turn be machines. To make sure that the abilities of each are effectively used, to make sure every man who worked is paid. This is Operation Alert, an exercise in what we hope will never happen, a grim game. In case of nuclear attack, what happens in Washington where the officials are who must lead and organize in case of the unthinkable emergency? Especially what happens to the military leaders who must arrange for defense and lead counterattack? What happens is they must disperse, for if they perish together, we are all lost. Operation Alert dispersed them by helicopter to special hideaway command posts, so organized that if one is eliminated, others will take over. Army and Air Force VERTOLs took part, working according to a plan set down long before, operating in foul weather, taking the indispensable men to the safe places, then acting as couriers among those places. Army generals moved out on one side of the Pentagon, Air Force generals moved out on another. This was the second time for Operation Alert, the second successive year in which VERTOL helicopters carried some of the nation's top generals, admirals, and high civilian officials of the Defense Department. The hurricane named Janet in Tampico, the operation named Alert in Washington, the foreign disaster, the threat, the need for readiness in our own capital, and the same shape dominates the skies. We have come a long way from the helicopter as a romantic toy, a far-off legend. No one stops to think anymore about the craft which can fly where no others can, land where no others can, do what before had been impossible. It goes over, it goes around, it hovers. It was no surprise that the officials all got where they were going in the right amount of time, tested their installations to see that they would work, and came back that much more assured that we were ready. A Texas tower. Readiness is many things. Here's another. A radar dome on stilts off in the ocean, about 100 miles east of New England. A full line of Texas towers is now in construction along our eastern coast, with radar ranges overlapping for a solid wall of warning out to sea. Between the tower and the mainland, there is one method of travel, the VERTOL helicopter. Here, the H-21 proves its reliability summer and winter in all kinds of weather. It can hop over the rough North Atlantic waters and bring new crews and food and portable radios and books, service equipment and mail call. Airmen who man these towers are limited to a month's duty at a time. They must get back, but first their relief crews must come out. This is how they do it. The Texas Tower system extends our defensive air effectiveness and therefore our safety against enemy air attack 200 miles further eastward. Building the towers was a prodigious job, but it would have counted for very little without getting the men out there to man them. On a mountaintop in New England, the military has a research installation whose work is marked top secret.
Here again, the duty is hazardous and the life of the men isolated. The terrain is impassable, and snow blows in the high winds almost all year round. We are now 4,000 feet up, the temperature 47 degrees below zero. But Vertols can fly in temperatures as low as 65 degrees below zero. Once again, the helicopter makes it up the mountain, carrying incredible loads inside its airliner cabin or slung beneath its hull, able to fly under the most turbulent air conditions encountered on the mountain. What could have taken a week has taken a few hours, and the copter takes off to return to the foot of the mountain and to go on a similar mission another day soon. Far in the trackless wastes of northern Canada, we're building something called the Dew Line, a distant early warning system of radar installations, a frontier of alertness stretched out across the top of the continent. This Vertol came in an Air Force transport and is put together right out on the airstrip in the shadow of the plane which brought it. Our men are at radar stations scattered along the Arctic Circle, each isolated in the wilderness. This is how each is connected to the other. Radar equipment crated and ready to move. The copter, painted in the distinctive red of our Air Force's Arctic Air Command, moves first. The crate weighs almost 1.5 tons, and inside is a delicate mechanism. The huge weight must be moved without jarring. The pickup is neat, and the voyage uneventful as the helicopter travels above snow, frozen marsh, uncharted wasteland, through which no road goes, and no road could be built economically, since no one wants to go anywhere along the way, but just from here to there. At the other end, the radar station, which needs this warning gear to be useful. There is perhaps $1 million involved in this single operation. More important, any one of these installations, perhaps this one, may give the warning which will save untold lives. This is the mechanism which will give the warning. It is important. It comes in just right. It does. The Army is using the Vertol helicopter as the carrier of its sky cavalry. Pictures made at an exercise in Oklahoma show how this works. Mobility, load-carrying ability, versatility. These are called for to the fullest in this exercise. A full combat front can be manned, advanced, evacuated, supplied in minimum time. Enemy strong points are leapfrogged for daring hit-and-run attacks. And before the strong points are brought to bear, the attackers are gone. Again, these are simulated tactics we hope we never have to use. Perhaps if we know them well enough, we never shall.
At the Morton, Pennsylvania plant, as in all aircraft plants, tomorrow was here yesterday. The day after is on the drawing boards and in the planning rooms. The researchers and experimenters are forever bringing new situations for the computers to analyze, new hypotheses and theories. Bigger vertical takeoff and landing craft, faster ones with greater ranges, higher speeds. And tomorrow's dreams of the conquest of the air we live in. The machines are helping them consider problems far into the future at a speed that makes it possible to apply the solution in time for the next engineering advance. And the machines are only as good as the men. The answer you get is only as useful as the question you ask is visionary. The machines can't tell you what tomorrow looks like. They can tell you if your dream will work. You need, above all, the men to plan ahead, to operate the big plant, to tell the machine what to think about, what question to answer. Decisions here become facts, long distances away. Refueling in midair now allows the helicopter to move over widening distances in shorter periods of time. Skyways without runways are being extended, and the unique silhouette grows familiar on every horizon in the world. On Pikes Peak, in the heart of the continent, nearly 3 miles up into the clouds, you can see it. Or over the surface of the sea, it does its work, towing or carrying, lifting or delivering, over short distances or for long journeys, bringing goods, supplies, emergency parts for the purposes of commerce, for the needs of an alert defense, bringing men where they must be, carrying things where they are needed. The helicopter is always moving, always filling the big jobs and little jobs. Around the clock, around the world, you will find Vertol helicopters at work.